गुड मॉर्निंग स्टूडेंट। सो हम लोग कर रहे थे ड्रग एक्टिंग ऑन सेंट्रल नर्वस सिस्टम, जिसमें अभी तक हमने क्या किया है, जनरल एनेस्थीसिया किया। अब जनरल एनेस्थेटिक्स के बाद नेक्स्ट जो आते हैं ड्रग्स वो है हिप्नोटिक एंड सेडेटिव्स। हिप्नोटिक एंड सेडेटिव्स या सेडेटिव और हिप्नोटिक्स जनरली एक साथ टर्म यूज होती है, बट इन दोनों का डिफरेंस जो है they have a little bit difference। इनमें डिफरेंस है। जैसे जो हिप्नोटिक्स होते हैं वो जनरली प्रोड्यूस करते हैं स्लीप, जो कि रिजेंबल करता है नेचुरल स्लीप से। सिडेटिव्स लेकिन जो सिडेटिव्स हैं वो क्या करते हैं, एक्साइटमेंट को रिड्यूस करते हैं, और कौन सा इफेक्ट, एंजाइलोटिक इफेक्ट्स जो है वो प्रोड्यूस करते हैं। हिप्नोटिक एंड सिडेटिव्स दोनों के दोनों क्या है, आपके सीएनएस सिस्टम को, सेंट्रल नर्वस सिस्टम को डिप्रेशन कॉज करते हैं। एंजाइलोटिक क्या होते हैं, जो एंजाइटी रिड्यूस करते हैं। दे आर मोस्टली सिडेटिव्स। Okay, so sedative and hypnotics is a chemical substance which reduce tension, anxiety, and induce calmness. That is sedative effect, or sleep means hypnotic effect. Low doses of these drugs exert calming effect. Means अगर वो calming effect produce कर रहे हैं low doses पे, तो क्या मतलब है कि वो आपके क्या है, हिप्नो जो वो हैं आपके सिडेटिव्स हैं। लेकिन हायर डोज पे दे हैव अ स्लीप प्रोड्यूसिंग इफेक्ट, दे इंड्यूस स्लीप, मींस वो क्या है, सिडेटिव की तरह काम कर रहे हैं। हिप्नोटिक एंड सिडेटिव ड्रग्स डिप्रेस सीएनएस। ड्रग्स लाइक ओपिएट्स कैन आल्सो प्रोड्यूस दीज एक्शंस। मींस जो ऑपियोइड एनाल्जेसिक्स होते हैं वो भी ये सेम इफेक्ट प्रोड्यूस करते हैं। लेकिन हिप्नोटिक एंड सिडेटिव से वो कैसे डिफर होते हैं, बिकॉज वो ये जो है ये आपके जो मूड है उसको ऑल्टर किए बिना और पेन को ऑल्टर किए बिना ये जो है सेंसेशन ये सेम प्रोड्यूस करते हैं। सो hypnotic and sedatives are the chemical substance used to reduce tension, anxiety, induce calmness means sedative effect, or induce the sleep, and drowsiness means hypnotic effect. Most such drugs exert quieting or calming effect at low doses and sleeping inducing effect at large doses. So same drugs can be used as a hypnotic and sedative according to their dose. Up next, if we look at the figure, these CNS effect is produced by the almost the same drugs depending upon their dose. If we increase the dose, so firstly the sedation is caused, then hypnosis is caused, and last anesthesia. And if the dose is more, then a coma can also produce to a human being. These are the examples or the classifications of the hypnotic and sedatives. The first class includes barbiturates, in which drugs are methotrexate, phenobarbital, thiopental, and thymol. These are the drugs. Then next are the benzodiazepines. Benzodiazepines includes diazepam, midazolam, clonazepam, nitrazepam. Benzodiazepine include diazepam, midazolam, clonazepam, nitrazepam, flunitrazepam. These are the drugs which comes under the class of benzodiazepine. Next are the drugs glutamide. In class glutamide, piperidine, diones are the drugs. Next is the mefrobromate. Mefrobromate, in case of the mefrobromate, propanediol is the drug. Next are the meprobamate. In case of the meprobamate, propanediol is the drug, and in case of alcohol, ethanol, chlorhydrate, paraaldehydes, these are the drugs. Then buspirone is the drug, zolpidem and zolpidem. These are the drugs which induce hypnotic and the sedative effect. So, barbiturates can further be classified depending upon their duration of actions. If we look at this picture, long acting means one to 2 days, in which phenobarbital is the drug. Short acting 3 to 8 hours. In this, phenobarbital is the drug, and sacobarbital and amobarbital is the drugs. Then if we look at the ultra short acting, they act for the 20 minutes or less than 20 minutes. This in which drug is included is a thiopental. Now next is the mechanism of barbiturates. If we look at the mechanism of the barbiturate, how it is it bind to a specific receptor named as GABA A, which is a subunit at the CNS neural synapse, facilitating GABA mediated chloride ion channel opening and enhancing the hyperpolarization. If we look at the effect of the barbiturates, it have dose dependent CNS depressant effect, which includes sedation, relief of anxiety, amnesia, hypnosis, anesthesia, coma, respiratory depressions, steeper dose response relationship than the benzodiazepines. Now, next are the barbiturates. If now in next we will talk about the chemistry of the barbiturates. So basically, if we look at the structure of the barbiturate, it contains the barbituric acid. That means it is a barbituric derivative. Hypnotic and xylotic effect discovered in early 20th century. Until 60s, the largest group of the hypnotics, that is more hypnotic and then anxiolytic, act by both enhancing GABA responses and making GABA opening of chlorine channel in the absence of the GABA, increase the inhibition of the CNS, also block the glutamate receptor. High risk dependence, severe withdrawal symptoms, strong depressant activity on CNS that include anesthesia. At higher dose, respiratory and cardiovascular depression, very little used today as a hypnotic, only for the epilepsy and anesthesia, these drugs include. So if we look at the structure of the barbituric acid, it is a 6-member ring which contain 2 heteroatom, that is nitrogen, and at 3 position, carbon is attached to a oxygen. These are the structure of the drugs. So if we look at the structure of the drug, we will find a common in these all the structures. Barbituric acid is the common, and at the C6 position, there is a different substitution occur. In case of the phenobarbital, if we look at the structures, phenobarbital and methylbarbital, they have similar structure. The only difference is at the N1 position. In case of the phenobarbital, there is no substitution on the nitrogen, and in case of the methylbarbital, nitrogen is substituted with methyl group. And now if we look at the structure of the sacobarbital, at C6 position, there is a different derivatization. So these are the different drugs. These are the different structures of the barbituric acid containing drugs. Now, different barbiturates vary almost in their duration of action. If we talk about the phenobarbital, it is a long-acting drug used for the anticonvulsant therapy. And if we look at the IUPAC name of the barbituric acid, it contains 5-ethyl, 5-phenyl. At the barbituric acid, 5-ethyl and 5-phenyl. C5 is di-substituted, means 2 times it is substituted. One is from the ethyl chain and one is from the phenyl group. So next is the thiopental. Thiopental is the very short acting and very lipophilic. It is redistributed from the brain into the tissues. CNS concentration fall below effective level used for the IV as an anesthesia. And if we look at the structure, it is also at C5 position, it is also di-substituted. One is the 5-ethyl and one is the 5 at C5 pentyl group is attached, isopentyl group is attached. Now, barbiturates term is used for the drug or the derivatives of the barbituric acid, which is a cyclic uride. If we look at the structure of the barbituric acid, this is the urea. So it contains urea, and the uride diuride cycles is there. So if we look at the urea, so it has a similar kind of the structure. If we look at acyclic diurea, there are the two urea groups are attached, and in case of the cyclic urea, three urea groups are attached. Now thus they are the derivatives of the hexahydropyrimidine 2,4,6-trione. The acidic nature of the barbituric acid is due to the lactam-lactam tautomerism. So in case of the barbituric acid, there is the tautomerism occur. It can, if we talk about in a basic way, like a enol and keto and enol form, it also form the lactam and lactam tautomerism. This is the structure of the keto form, and this is the structure of the enol form. Barbituric acid and its 5 monosubstitutive barbituric acid at physiological pH exists in fully unionized form, means when it is singly substituted at C5, so it acts as an unionized form, so they cannot penetrate through the blood-brain barrier, and then they cannot penetrate to the blood-brain barrier. Therefore, in case of the most of the barbituric drugs which act as a hypnotic and sedative, they have to cross blood-brain barrier because they have to act in a CNS, that is central nervous system. For drug to be reach to a CNS, that should be drug should it is a compulsion for a drug that it should cross blood-brain barrier and reach to the CNS. However, 5,5 di-substituted or 1,5 tri-substituted barbituric acids जो हैं वो weakly acids होते हैं, वो weakly acids होते हैं और वो क्या करते हैं, easily आपके blood-brain barrier को cross कर पाते हैं और CNS तक पहुंच जाते हैं. They can easily penetrate to the blood-brain barrier and act as a hypnotic and sedatives. Now, if we look at this, although these compounds are relatively weak acids, the salt of these barbituric acid easily formed, and then when treated with alkali, when barbituric acid is treated with the alkali, it can easily form the salt. Hence, their monosodium salt can be obtained, which are water soluble, that is phenobarbital sodium. 5-ethyl 5-phenyl derivative of the barbituric acid, that is phenobarbital, was introduced in 1912 as long acting barbituric acid. Replacement of the phenyl group by isobutyl radical gives the compound butobarbitone, which is an intermediate acting compound. The duration of the action is further reduced by the phenyl group of the phenobarbitone is replaced by the cyclohexyl 1-enol group as in cyclobarbitone, which is a short-acting barbiturate. If C2 oxo group is replaced by the thoxo group, that is double bond S group, then the thiobarbiturates are obtained. Example, thiopentone sodium. So barbiturates, though they are potent drug, but they possess dependency liabilities. That means if we, for a long period of a time, if we consume barbiturates, our body get dependent on these drugs. Thank you. I hope this video is very informational for you. In next lecture, we are going to study about different drugs comes under non-barbiturates, and that includes benzodiazepine and different class.